Hello everyone. Okay, previously we have completed the Newton's laws of motion chapter. In that we have completed the subtopics like friction, circular motion, dynamics of the circular motion. All these things we have learnt. Okay, after that now we are going to start a new chapter which is work, energy and power. Right? Let us see the what is work. Okay, so what is work? So whenever you take an object and apply some force on it, in the direction of the applied force, if the displacement is there, then the body is set, a work is said to be done on that object. Okay, so what is that? So first, a force should be applied on an object. Second, there should be direction, in which direction the force is applied. In the same direction, the displacement should be there. Or motion should be present at the point of application of the force. Okay, motion should be applied means motion should be present at the point of application of the force. Okay, wherever you are applying the force, in that direction we need to be having the motion. Let us suppose there is a block over here placed on a ground. On this, a force F has been applied. Suppose this has a mass M. Okay, now at point A, it is there initially. When the block is at point A, the force is applied. Okay, now after some time it started moving and it reached the point B. Okay, so the distance or the displacement, because it is in a straight line, we can say that distance or displacement same. Now the displacement is along the direction of the applied force. Right? The displacement is along the direction of the applied force. So where the point is applied, suppose here the force is applied at that point of application, there is some motion of the object. Right? Now, so whenever a force is applied, if there is a displacement along the direction of the applied force, then work is said to be done. Okay, then work is said to be done. Right? Okay, so work done generally it is denoted by the letter capital W. Usually in the gravitation chapter, weight W will be denoted by the W, capital W generally, but here let us take that capital W indicates the work done here. Throughout the chapter, let us take that W. So it is a scalar quantity. What is that? It is a scalar quantity. Okay, it is a scalar quantity. It can be positive. This scalar quantity can be positive. It can be negative or it can be zero also. Okay, how it is going to happen, let us discuss a little bit after the discussion of the formula. Okay, what is the formula? Let us see that. So work done W is equal to, it is a product of force and displacement in the direction of the applied force. What is that? Product of force and displacement along the direction of applied force. So that is work done. Force into displacement along the direction of the applied force is called work done. So what is the work done formula? W is equal to force into displacement. Right? Now, so now if you observe what happens when the force applied is making an angle with the direction of the displacement. Let us see. Suppose this is a block. Okay, a force F is applied here, making an angle theta with the horizontal. Okay, let us take an object. On this object, a force F is applied, inclined to the horizontal. See, it is making an angle theta with the horizontal. Now, after some time, this block came here. Suppose this is the point A and this is the point B. Initially, it is point A. From point A to point B, it has reached. Okay, whatever the displacement is there, it is along the horizontal direction or not? Yes, it is along the horizontal direction, and let us say this S is a displacement here. Now, in this case, when the object started moving from A to B and finally it came to rest, suppose, what is the work done in this case? What is the work done? Force, product of force and displacement in the direction of the applied force. See, displacement in the direction of the applied force, what is the meaning of that? Because of this force, it is not entirely moving in this direction. Because of this force, entirely, not entirely, means if you take this force, you can resolve this into two components, one along the horizontal direction, one along the vertical direction. We have two components. So this component, as it is having contact with the theta, it becomes F cos theta, and this becomes F sin theta. Okay, now we can clearly say that because of only F cos theta, this block is moving from A to B. Or because of only this horizontal component F cos theta, the block has the block has moved from point A to point B. Isn't it or not? Now we can say that work done is equal to force into displacement into, in place of that, F cos theta into S. So this becomes F S cos theta. Right? So now you will get it out. So earlier you have directly written F into S. Why we got this W equal to Fs cos theta? Why not here? There is no cos theta here. Of course the cos theta is there here. It should be there here also. But in the first scenario, if you observe, what is the direction of the force is along x-axis. X-axis direction this is. Let us consider horizontal x-axis, positive horizontal x-axis. Right? Now, the direction of the displacement is also same along the positive x-axis. Now, what is the angle between the force and displacement? 0 degrees. So here theta is equal to 0 degrees. So work done is equal to F into S into cos 0 degrees. Cos 0 is 1. So W, work done, is equal to F into S. Understood? That's how we got the formula at the beginning. Okay? F into S. Now, so if you remember something, A bar dot B bar can be written as AB cos theta. This is also known as scalar product. In the vector form, in the vector products, we have discussed this. A bar dot B bar equal to AB cos theta, which is also known as dot product. So if you observe AB cos theta, here also Fs cos theta. So these are also, force is a vector quantity, displacement is also a vector quantity. Here the product of the two vectors is there. So if this we can write it as vector F bar dot S bar. See, if we can write like this, we can write this Fs cos theta in terms of F bar dot S bar. Yes, why? Because F bar dot S bar is nothing but dot product of the force and displacement. This is the dot product of force and displacement. F bar dot S bar is nothing but the dot product of the force and displacement, right? So whenever you do the dot product of something, A bar dot B bar, you will get AB cos theta, where A and B are the magnitudes here, A bar and B bar are the vectors here. Okay, A is the magnitude here, A bar is the vector here, B bar is the vector, and B is the magnitude of the vector B. Similarly here also, F bar, S bar, these are the, what are these? These are the vectors, and F, S are the magnitude of the vectors. Clear? Right. So we can write the work done is nothing but the dot product of the force and displacement. Clear? Right. Okay. So now let us see why, in which case you will get the work done is positive, in which case you will get negative and 0. Let us start from the positive. Right. So whenever the force, we apply force, if the object is moving along the direction of the applied force, then we can say that it is having positive work done. So this is what the discussion we had for the definition of the work done. Yes, not like that, just let us see that. Okay, suppose here we have applied the force F, and from here it started moving, and finally it reached here, the displacement is S. So what is the displacement direction is along this direction. So the angle between the F and S is nothing but theta is equal to 0. So then W is equal to F into S into cos 0, that is equal to F into S into 1 F into S, right? Now, is it the only way? No. Let us take another example. Suppose this same block is there. Okay, we have shifted this from here to here, height h. So here the applied force is along this direction, upward direction. Applied force in the upward direction. In which direction is the displacement? Displacement is also in the upward direction. Now because of this, theta is 0, because displacement and force both are in the same direction. Here also we can write theta is equal to 0 and work done is equal to F into S. Here it is H, positive value. F is positive and H is also positive. See, here we are talking about only the magnitudes here. F, S, cos 0. Here also you will get F into S into cos 0. Here S is H. F into H into cos 0. When we say into cos theta, W is equal to Fs cos theta. What are these F and S? These are indicating the magnitudes of the vectors, not the vectors itself. Understood? These are only representing the magnitudes of the vector, right? So Fs into cos theta. So you will have this cos 0 is equal to 1. So you will get work done is equal to force into displacement. Here W into H. So whenever, suppose you take a horse, it is pulling a cart, horse cart is there, it is moving in the same direction. That is, work done is positive in that case. Okay, suppose there is a piston. cylinder and piston is there. Suppose this is a cylinder and this is a piston. Inside this gas is there, compressed gas is there. This compressed gas will be applying force on this piston. So if by the compressed gas is applying force on this piston, suppose this piston is not having any constant force, means if it is having the constant pressure from outside, if it is having constant pressure from outside, from inside it is having the applied force. Because of this, the piston is allowed to move. So if at all it is allowed to expand. When it expands, this piston moves up, that means it is getting expanded. So the volume is increasing, right? Whenever the volume is increasing, it is getting it expands. Now that is the meaning of it expanding. So when it is expanding, now what is the work done by the gas? So see, force applied by the gas is in this direction. Because of this, the piston will move up to here. So this is the direction of the displacement. So force of the gas and displacement of the piston. Force on the piston and displacement of the piston, both are in the same direction. Here also work done is positive. Understood? So this is